Okay, on my last video, I actually got ahead of myself there, and I did both a circuit play and the first code play by changing the code to activate pin 12. I've now put everything back to where it was initially, and I'm looking at the second code play where I'm currently running the program that was compiled with 1000 in the delay, and now I'm about to compile it with 2000. Actually, you can see it here. I've got 2000 in each of the delays. And as that completes its compiling, we notice that now the LED is blinking half as frequently. And so as I understand it, the delay is actually, I'm not sure how calibrated it is, but I would suspect not too bad, is probably in milliseconds. So when I had 1000 in there, I had a delay of 1 second between switching on and off. And now that I have 2000 milliseconds in there, it's 2 seconds. And if I were to choose to, if I wanted to triple the delay, I would just put in 3000 milliseconds. And if I wanted it to be half a second, I would put in 500 milliseconds. And actually, why don't we just let me just verify that we can make this thing move pretty quickly by putting in 500 milliseconds and letting it compile. So there you see I've got 500 milliseconds in. We'll let it compile, and we'll see that now that it's compiled, it is running twice as fast as it did when I had 1000 in there. Okay, so I think the key thing we've learned here is that we can very precisely control the timing of something given that we have this delay, which is actually in milliseconds. So we can probably do some pretty fancy stuff here. We'll have to think about what maybe some things we can do with LEDs here beyond this. But okay, so that concludes the code challenge 2.